Hey guys, how's it going? So today we're going to look at this problem called click data schema. So we are told that we are setting up an analytical tracking application for our web app. How will you then design the schema to represent the client click data on the web? So I think this is quite an interesting problem. So let's see how we can actually go about this. Please note that we're not only going to design the schema, but I thought just for educational purposes, it will be good to kind of like also design the pipeline. So for those who quite want to understand the concept better, so you can think of like when we talk about click, we're talking about a small piece of data generated in real time based on the user behavior. So as the user interact on the web application, and we can actually be collecting that data going into our servers. Okay, so one of the reason we're using this data is because we want to do like a recommendation system. So machine learning is moving away from batch based recommendation system to a real time. So as the user interact with the application, we send that data to something like Kafka, we process it with Flink, and we store the results in like Redis or something like that. So the application get your clicks in real time and can actually recommend you products as you are interacting with those. So we can actually see that we have A/B testing, so we can see which part of the application the user like to access, something like that. So yeah, like I said, why we might want to use this is because we want to analyze the amount of time the user spend on the application and also the sequence of clicks a user makes. So also this helps us to design our application in such a way that we maximize the user time on the application, or we maximize the purchase or something like that. Okay, so from the schema's perspective, given that I like to kind of like raise certain things before you jump into the schema. So we have to define a session. A session, you can think of it as like some sort of like amount of time the user spend on the application, right? It could be the minimum or maximum time for like a time that the user spends. So there's so many things that define a session. It could be when the user clicks on the site and they access it, or when they leave. It could be based on the time that we set that, okay, after whenever from the time they enter the site, then after maybe 1 minute we that's a session or something like that. So we're gonna jump into that, but in a second. But the point that I'm raising on this point is that you need to understand the dates chronology, understand how your data is coming in terms of the dates. So for example, what is the maximum and minimum time of a session? And usually a session can run from 20 to 50 seconds, including 1 minute. So it cannot only be time based. Just know that there's certain things that can actually define a session as we go on. We'll see that. So the reason why you should understand your data granularity, and because it helps you to be able to design your time and dates. For example, we know that if an event occurs, for example, it occurred at this time, we have to store our data in a second granularity. So that's how we want to store it. So it's going to be something like this. So our timestamp is going to look something like this, and we're just going to store those events, right? So the reason I said the schema cannot, the session cannot only be defined from the time perspective, because it can be that the application timeouts could be about navigation. Like I said, the user could leave the application. So some of the companies, what they do is that they tend to say, okay, when the user leaves or when the user enter the site, that's like the session or something like that. Let me show you this SQL code that I wrote for solving the problem. So it was something like this: user by session type. So it was from Facebook. It was a question, and we can see how Facebook, I don't know, this is how they do it, or maybe this was just an interview question, but we can see that their session is defined as the time difference between a page load and a page exit. So when the user page load and when the user page exit. So that's what define a session for Facebook, whereas with other companies they define it as time. So this was also a problem to kind of like calculate the session time. So just showing you that. So with the session in mind, as you will be explaining to the interview all of this information before you jump into like the schema itself, kind of like have to erase all of this bottlenecks, right? So the another thing that we need to take into consideration is the action type. I personally came up with this because I thought we could have action type, like maybe the user scrolls and clicks and hover. For example, let's say you're on LinkedIn, let's say this isn't a web application and there's a post. So the reason I'm creating action type, and there's a difference between action name and action type, which we're gonna explain action name, but for action type, these are like scroll, when the user clicks, or when the user hover on something. So sometimes the user do not necessarily click on the post. They usually will read a post, right, but not click on it or not comment. That for me is still an interaction, right? They spend probably like on this post, as they're scrolling, they spend something like maybe I don't know, I'm just gonna say 30 seconds. Maybe it was a meme or something. And I usually do this on LinkedIn, right? I don't necessarily like or something like that. I'll see a post, then I'll look at it and it's quite interesting, but maybe I did not actually interact with it. So scroll is quite important also, that we capture that, right? So that was my assumption personally, that okay, I'm just going to have this type. So we have action name. So when the user add to cart, this is an action name that they did. They call logout, they call click a product, pagination, or something like that. That's also a name. So with these things in mind, I think now we kind of like can design our schema. So this is our schema. User ID is going to be an int, so it's going to present the user that is on the session. We have a timestamp that we spoke about, which is going to be the ground length of seconds. Then we have an action type, which is going to be scroll or clicks. Then we have an action name, which is going to be add to cart. And I think there is a relationship between this, if you can think about it. For example, action, it could be action type, it could be like a click, then here it could be maybe cart, something like this. So looking at these two things, we can see that we can say, okay, a user click to the cart. That's how I personally thought about it, and something like that. Okay, so we can see, and also let's say maybe a product, they're on a specific product or something like that. We can also see maybe scroll or hover or something like that. So it can be hover that product, they hover this product. So we have a device ID, which represent if it's a mobile app or web application. We have agent. This is coming from things such as payload, how APIs work. Then we have URLs that we see, that which enables us to see which site or page that we're accessing the user. So as you can see, this is missing, right? It's missing something important. I don't know if you have seen that. Our schema is missing a session, which is very important, right? Because session is part of, it's very important for the click data schema. So why did I omit this? Because I wanted to kind of like educate maybe some folks how a session is calculated. And if I included it in here, but where is it coming from? How do we generate this, right? So let's see how some of the companies, they kind of like do this. So a high level design is that we have an application, we have a web app here, right? It could be a mobile app, and it could be from a desktop or something like that. Then we ingest the data as it comes in. We goes into Kafka or Pulsar. Then this is our data ingestion, our pipelines. Then we have a processing engine here. These things are happening, by the way, in real time. So Kafka is a log based. Then a Flink also is a processing engine that does the processing in real time as the data flows in. So we have a Spark structured streaming also is like streams the data in real time. But the point that I'm raising here is that as the user clicks, the data goes into Kafka. We process that data. By process that data, I'll get into that how we do it. That this data that is being processed could be thrown into storage like S3, Q, or depending on if it's a machine learning, it could be thrown into Redis for feature store or something like that. Then we have our dashboard here. Maybe one of you user interaction in real time. So the point that I was raising is that when I said processing, what do I mean by processing, right? There could be a lot of things that take care that happens there. But what I mean by processing, I'm talking about window operations. So I'm gonna introduce you guys to kind of like window operations, but Flink allows us to write SQL, write code in Spark, can process data in real time. So we have type of window functions that we work with. So the first window functions that we have is the tumbling window. So a tumbling window, we can think of it as we have a fixed size of a window. So let's say we have like a window is going to be 1 minute. So here we can see it's 1 minute, window 1, it's 1 minute, then this is minutes 2, minutes 3, something like that. So this is all the users in this minute, right? All the users in this minute, all the users in that minute. So this is called a tumbling window function. So it works with a fixed window size that we actually supply. So there's type of these window functions, and but the point is that these window functions essentially they help us to create sessions, and this is happening in real time. By real time I mean Flink is gonna, let me show you the code in Scala. So this is the Scala code. So Flink is you're gonna have this data here, and as the data comes in, as you specify that window function, it's gonna make sure that it's gonna wait for all of those data to comes and fill in that specific time period that you've mentioned, which is a minute. Then after that, it's gonna say, okay, this is a session, go and store this. Let's go to the next session. As the user interact and the user is still interacting in that session, that means it's on the session 2, something like that, right? That's that. But that's not only tumbling is not only a window operation that we have. We have a couple type of window. We have something sliding windows. I think the one that I would also talk about is the session window, which is, I find it quite useful, especially in the machine learning application. So let me scroll to the right. So you can think of this is actually a session window. So you can think of it as it waits. It waits for the user interaction. So this is based on the user interaction. Let's say the user stop interacting with the application for a specific number of time, then it's just going to create a session for that user. So I feel like this is a very smart way so to kind of like create sessions, because some users might not be there, and I think it saves resources, because if you said this user came to the site, maybe they spent 20 seconds, but the next 30 seconds they were not inactive. So it saves resources. And remember that with Flink, this data is being materialized. So you want to minimize the data that is stored in memory. So that's why you need a clever way to actually save this. So I think I really like this concept. I'll leave the link, guys, for you to read if you kind of like don't understand this, so that you can read it on the Flink side. So I hope you kind of like understand how sessions are designed. So you can think of this data is in real time, it's coming, you're interacting on YouTube or Twitter, this data is going in Kafka, then Flink, it's just doing all of these processing. As you click and click, there's a window period that, okay, after maybe if you stop interacting with the site, then we're gonna create a session for you, something like that. So we saw with that question from Facebook, they LC use page load and page exit. So we're gonna have something like this, whereby we have session ID, user ID, device, begin, and session. So, but the point is that now we have the session ID, and you understand how we get in this. So this was an example from AWS. So it's something that you might actually end up having as the final table. So you're gonna have your session ID. You'll understand which session it was, and you'll have the user ID, device, timestamp, event, and all of the stuff. And by the way, it depends also. We were told that we should design a data schema for this. So I think you just ask your interviewer if like they want a denormalized or normalized table. Should you like create a table to store this and store them as an int instead of as a varchar or something like that. So it's something that you can discuss with them, because I'm thinking from an application perspective, and but it's something that you can actually discuss and stuff like that. But yeah, I think that'll do it, guys. That was it, and thank you for tuning in, and I really appreciate it. See you in the next video. Bye.